Morning, statistics students. Just wanted to give you a brief introduction to sections 9.5 and 9.6. They deal with the same type of problem. It is titled paired differences or estimating the mean differences. Now, how does this different than 9.3 and 9.4? In 9.3 and 9.4, we dealt with two sets of data and we were comparing their means. We were given means of each set of data and the standard deviation, and we could compare them. We could find an interval and see what the difference is. And you're gonna kind of go, okay, what's the difference between the two? There really doesn't seem to be much difference. In that section, we did two sample T's. In this section, we're only going to do one sample T, and it's because we're going to take two sets of data and we're going to subtract them to see the difference, and we're going to use the differences rather than the two sets of data. Now, there is a way where you can enter in to your calculator the two lists and then subtract them, but in most cases it's very easy to subtract the two amounts and come up with your own list of differences. So I will refer to these problems as mu difference problems. And if you think of the letter mu and then put a little d, that's all it is. And that's all we're looking for. In this section, when they ask you to compute the mean and the standard deviation for the differences, you're going to use that list just like we did in the first semester, and you're going to put that into the list in your calculator, and then you're going to do a calculation and you're going to do one variable stats, something we haven't done for a while, but that's something that you will use and utilize to find the mean and standard deviation. And I will show you an example a little bit later in this video, but that's kind of an overview of it. Let me give you some examples of what a mu difference problem might look like. One of the key characteristics of a mu difference problem is it's a comparison of a before and an after. So let me give you an example of one that is very applicable to you guys. Let's say you took the SAT score or SAT test and didn't study, didn't prepare, didn't take a prep class, and you got a certain score. And then let's say in 2 months you took the SAT again, but in that 2 months time, you went to a Princeton review course. Well, let's say that Princeton wanted to advertise what difference it would make if you took their course. So they would take 10, 20, 30, whatever the number of subjects it would be, but each person would take the SAT before they took the prep course and then one after the course. Now, obviously, hopefully if you've taken that and spent the money on the Princeton review, that your score would go up. So let's say your SAT score was 1,500 before you took the preview, and then after the Princeton review, your score went to 1,800. Well, it increased by 300. Now, is that something that would happen for everyone? Well, we don't know. That's what we would have to kind of study and see. So what am I trying to get you guys to see is that the same subject took the SAT before and after. And so that's the relationship you need to look for in these problems to see if you're doing a mu difference problem or whether you're just simply doing a two sample T. Another example would be diets. So here's my weight before I went on the diet, here's my weight after I went on the diet. I am still the subject. I'm the same subject before and after, and we're looking for a difference. Now, I want to use those two examples. So the SAT, I would want my score to go higher. So if my second score is higher, and I'm always going to subtract, I'm going to go the before minus the after, that would mean I would have a negative number for SAT. If I went from 1500 to 1800, I subtract 1500 minus 1800, I have a negative 300. So be careful about what you see that negative 300, what does that actually mean? And you need to keep in mind in the context of that problem of SAT, it means your SAT score is rising. So don't forget that. Now, in our second example of the diet, we want the second number to decrease. So if I go from 180 pounds to 160 pounds, I've dropped 20 pounds. But when I subtract it for a mu difference problem, I'm going to go 180 minus 160 and get positive 20. So even though it's kind of contrary, it seems as though positive 20 would mean I'm increasing my weight, and the negative 300 in the SAT question seems to mean that I'd be decreasing my SAT score. It's the opposite. So remember that, keep that in mind. You have to, what's the context of my problem? Let me give you another example within the world of athletics, and particularly track, in different events. So let's say I'm running, and I run a race, and my time comes out, and this is at the very beginning of the season. I haven't done any training, and so they tell me, and now after 6 weeks of training, I run that race again and I have a time. We would like to see that time decrease when in that event. So again, it's a positive value when you go the before minus the after. Now, let's say instead of running a race, let's say I'm a jumper, and whether it's a high jump or triple jump or long jump, maybe it's a throw, maybe it's the discus throw, maybe it's the shot put. In those cases, if I try to throw and I get a distance, then I train for 6 weeks, I want my throw or my jump to increase. I want to go farther in my long jump. I want to go higher in my high jump. I want the discus or shot put to go farther. So if I subtract the before minus the after, I'm going to get a negative number. So remember, the positive and negative doesn't necessarily mean up or down, but you have to think in context of the problem, what does it mean? And so in the case of the throws and the jumps, we would like a negative difference. When we talk about the time of a running event, we would like that to decrease, and so we would have a positive. So just be aware of that. Look at the context of the problem. What are we looking for? Those kinds of things. So that gives you some information about that. We can also do intervals in these problems. You're just simply doing a T interval and a T test is what we're utilizing in this chapter. Now, one of the things you will use a little bit more in this section is data, because you'll enter the differences into your calculator in the list, and then you'll have to use data when you access the t-test and the t-interval. So don't forget that. Now, in this, I want to go over requirements. They do talk about requirements for paired data. So paired data result from the recording of two values of the same quantitative variable for each individual or each pair of similar individuals. So that's what we're looking for. And I've already given you a number of examples for that. Now, one of the things that they're going to have you do is they're going to have you look at the dot plots of situations. So if we analyze that, the differences here, and if you look at these numbers, they don't have a great deal of range. There's not a real significant outlier or two. And so because they seem to be fairly grouped, then this is going to be a situation where we can use this. So this is actually the graphing of the differences. The other ones were the graphs of the 2 bits of information. And this particular problem is not the same subjects, but they're very similar subjects. We have a set of twins, a twin A and twin B. Twin A went to a high income family, twin B went to low income family. We wanted to see the effect on IQ and see if there was any impact. And so that's the example of what's going on here. So when we look at this, we don't see any significant outliers. That's a good thing. That is going to mean that we're going to be able to use this t-test and do this actually. And so here's an example of literacy in different countries of male and female literacy rates. And so they're going to sometimes ask you to make a dot plot. Just make sure when you make a dot plot, it's fitting your information into that dot plot. Dot plot was something that just looked like this. This is a graph of the differences. Now in this case, this is not going to be a really, there's some real outliers when you look out here. These are real outliers. These are grouped here more specifically. And so anyways, this would not be a really good example to be able to do it. But sometimes they do that. So here's the twins. And if we were to enter these differences in our calculator, they show the calculation of the mean of that. You don't have to do that. All we need to do is, I'm going to, let's see. You're not going to see what I'm putting in. Just understand that I'm putting in the bottom numbers. In fact, so that I can do this, I need to do it this way. So I'm just going to simply put in 8 and then 5. All I'm doing is entering those single digit numbers. This way. Okay, I'm at 5, 8. So then 1, 6, -1. Remember when you do a negative, you're always using the negative down here, not the minus sign. It will give you an error if you do that. 10, 1, and 12. Now, so that you can recall this, you're going to go to stat and you're going to go to calc. We're not doing test yet. You're going to calc, and you're doing it from list 1. We don't want to have anything in the frequency list, so we're not going to do that. And then we calculate. And so the average difference is 5.83. The standard deviation would be 3.93 here. So you can see there's the mean. So our mean was 5.83, just like them, and our standard deviation was 3.93, which I said as well. So that's how you calculate the mean and the standard deviation. Now, they're going to ask you, I haven't gotten to the, what has happened? Oh, here we go. How to check for conditions to be able to do a confidence interval for the mu difference. Okay, so we have 2 things. And the reality is there's 3 things that you are going to look at, and you're going to see that. So random, paired data come from a random set from a population. As always, that's what we've been now. Normal or large sample. So again, if our population distribution of differences comes from a normal situation, we don't have to look at the sample size. Otherwise, if we don't know that, then we have to look and see if the sample size is greater than or equal to 30. Now, there's a special case. If the population distribution of differences has an unknown shape and the number of differences in the sample is less than 30, a graph of the sample differences shows no strong skewness or outliers, then we'll be able to do the difference. So there's this one kind of exception to meet all three of these things, or to meet that last one. So don't forget that this is new, this is different. Okay, so it's an evaluation of a graph, and many of your homework problems in Sapling are going to ask you to look and interpret that graph. And is it going to be okay to still do an interval for the differences? So don't forget that. Don't check that. So just keep that in mind. How to calculate, they have this formula, just you're going to do it using the calculator. So I've already entered this information. So let's look at what the answer is and we'll see if it comes up for us. Okay, so it's from 3.36 to 8.33. So let's go to our calculator. Now I'm going to expand this out so you can see it better. Hopefully you can see that. I'm now, since I have the data entered, I'm going to go to stat and then over to tests. And again, it's a T interval, number 8. Because remember, it's paired data, but we've taken the paired data and shrunk it to one set of data. And we have that already stored in the calculator. And I'm going to go to the T interval. And then I'm going to go to data. It comes from list 1. Frequency will always be 1. I can't remember what they said. The 95% confident. So, so 95% confident is correct. And calculate, and they're the same as they had, 3.34 to 8.33. They give us the mean and the standard deviation as well there. So in a problem, if they ask for the mean, the standard deviation, and the interval all the same, you can actually calculate it by doing the T interval, and it gives you the interval as well as this. Now, I want to point one thing out. If I was going to write the interval down, this is the way I would write it. I would go 3.34 less than, and then I would use mu, and then difference is less than 8.33. Now, what I want you to understand is in intervals in our previous chapter and a half, we've had numbers that we look at. And this is one of the reasons why this is included in this chapter. For proportions and for the two sample T's, we've been checking whether 0 is included. We are again checking whether Z is in, or 0 is included. If we look at this difference, 0 is not included because they're both positive. One of these would needed to have been negative for 0 to be included. So keep that in mind. We could have done a t-test, which is going to come tomorrow. You're going to look for test statistics and p-values, and that's where you're going to go to t-test. So it would be number 2. So we're going back to that. Now what do I put in for the null? Well, your mu difference is going to be equal to 0 on this. And so you're always going to put in 0 in these kind of problems. Comes from list 1, frequency is 1 again. Don't know whether it was not equals or less than, or I'm going to assume it would be less than because it came out to be a positive value. trying to even remember the context of the problem. So we're just going to choose that. And so we're going to calculate, and there's our T, that's our test statistic, pretty high one, 5.20. And this would not be correct. That I would have chosen the wrong p-value on that. So number 2. Okay, but that means that the second one went up. Okay, I just have to keep that in mind. And so there, it's this sample is not likely to occur just at random. So there needs to be an explanation. So in the context of this problem, what is our difference IQ scores? It means that students who come from, or these twins that were in high incomes had a tendency to have a higher IQ. That is what that was testing. Okay, one last question here, for example. Okay, so here is a problem where there was an experiment designed for testing depression from caffeine withdrawals. So they had these 11 subjects, and they were limited to not have any caffeine for 2 days, and then they were given a caffeine pill, and then they recorded what their depression state was, and then did the same thing at another time, did not have caffeine for 2 days, but then they were given a pill, but it was a placebo. It didn't have any caffeine. And here were their symptoms of depression, rated in some numeric value. So it says, make a dot plot of the differences. Well, the difference is, if I write them here, this would be -11, this, -18, -1, -4. Now, you need to know that keeping the negatives is important, because it tells us that there was a difference and the direction that it went. In this case, their depression increased. And as a result of the increase, the only one where we have a positive value is that last one. So if you look at all of those, again, we don't have more than 30, we have 11. But when we look at the differences, if we were to make a dot plot, they would be generally grouped in the same area. There wouldn't be a significant outlier, and they would be grouped together. So this would be okay to do that. So then it says calculate the mean and standard deviation. I'm going to, again, take those numbers, put them in my calculator, and let's see. So you can see we have -11. Oh, wait a minute. Gotta get to the right place. That. And then, okay, so now I'm going to do a new list. I'm just going to go -11, enter, -18, enter, 1, -4, enter, -6, enter, -19, enter, -6, enter, -3, enter, -13, enter, -1, enter, and 1, enter. Okay, so now we've entered all that information in, and they want us to calculate the standard deviation. And if you look farther down, they also can say construct and interpret a 90% confidence interval. So So since I know I have to do the interval, I'm just going to go to tests and I'm going to do the T interval, number 8, and it's under data, but now I need to change my list. So second list 2 tells it to access list 2. Well, frequency is always 1, 90% confident. So confidence level of 90%. And there's our interval. Our interval goes from, would be expressed in this fashion, negative 11.1 mu difference to negative 3.6. And then our mean is negative 7.36. And our standard deviation would be 6.92. Now, remember the standard deviation is not a negative. It won't be a negative value because it's just always talking about the average difference. Now, what you need to understand from this is it does ask us to interpret this. And so if I'm going to interpret this, it does not include 0. Both numbers are negative. And so the depression of the people, and it's the same person, different compared to the taking of the caffeine as compared to taking the placebo, it went up, their depression rate went up by somewhere between 11 and 3.6. And so, yes, there is a significant difference here. And so it does the interval from question 3 provide? Yes, it provides convincing evidence that caffeine deprivation causes an increase in the average depression score for subjects like these. Okay, so keep that in mind. And this doesn't, you can't, notice it says subjects like this. It doesn't mean we can apply it to the whole population, but it is something that we can apply to this type of group of people. And it may give us some indication about the whole population. So that's the idea of mu difference problems. Sorry this took this long, but hopefully you listened to this whole thing and saw the examples. You can read through that in the book as well as you can replay this. All right. Good luck this week. And if you have any questions, please don't hesitate to come into Zoom.